Hello. So now I'm going to do a word problem here. Now the first technique I'm going to do to solve it is I'm going to draw it, and I'm going to make a couple of equations that are going to represent certain quantities. We're going to solve those, and they're going to allow us to find the answer to the problem. And then I'm going to use what we've learned about graphing lines to kind of visualize certain important features about the solution. So let's begin. So let's first read it together. Jessica and Janet are 250 miles away from each other. They begin driving toward each other at 30 miles and 45 miles respectively. How long will it take for them to meet? And from where they began, will they meet? Okay. So the first thing we're going to do here is we're going to draw a picture, okay? So here I have my, let's say this is where Jessica is right now. Let's call this location 0. And let's say this is location Janet, obviously at location 250, right? Because she's 250 miles away from Jessica, okay? And let's say that this is the road that goes between them. So now, if I want to say, so now we can look at this problem again. Okay, once we've drawn a picture, we can look at it again. They begin driving toward each other at 30 miles and 45 miles respectively. Okay, so Jessica's going to be driving at 30, Janet's going to be driving at 45 miles an hour. Okay, so let's call D Jessica's distance. So D in terms of time in hours is going to be 30 T. Let me explain why. So this is going to be Jessica's distance or Jessica's position, okay? Wait, let me write that a little bit nicer. I'm sorry about that. So we're going to let D, let's let D1 be Jessica's position. And we're going to let D2 of T be Janet's position. Okay. So in Jessica's case, she's driving at 30 miles an hour. She's starting from 0. So 30 times the number of hours she drives will get us where she is. Now, in the case of Janet, Janet's going to be driving towards Jessica. So Janet is starting at 250 miles from the starting location, from the 0, in terms of Jessica's position. And so since she's going to be coming this way, her location is going to be 250 minus 45T. It's 250 minus 45T because if we just look at 45T by itself, first of all, Janet's driving at 45 miles an hour. So if T is in hours, 45 times T will be how far Janet's driven. Janet is going to be driving this way. So her position is going to be 250 minus 45T because we will remove from 250 45 times T for T hours because it's 45 miles an hour. 45 times T will be how far she's gone. 250 minus 45T will be her position along this line for T. So now, this is the position of Jessica. This is the position of Janet. So if we want to find out where they meet, what we're really trying to say is, where will their positions match, right? So in order to find that out, we're going to set these equations equal to each other. I'm going to set this position equal to that position, because that will be when they meet. Okay, so let's look at it together. So that'll be 30T equals 250 minus 45T. Now, in order to solve this, I need to bring this 45t to this side. Okay? So plus 45t. Since the 45t is being subtracted here, I have to add it to get rid of it on the right hand side. But whatever I do to the right, I have to do to the left. So I add 45t to this side also. This gives us 30t plus 45t is going to be 75t. Okay? And that's going to equal 250. And let me do that for you here on the side so that you can see how it's done. And so you can have no doubt that you can do it. 0 plus 5 is 5. And then 3 plus 4 is 7. Okay? Okay. Now, once I'm here, how do I get the t by itself? I divide by 75. So the time at which the positions of Jessica and Janet match occurs at 250 divided by 75 hours. So now, if we think about this, that's not a time that we want to think about. You know, it's an ugly fractional time. We want something that's more relatable. 2 hours, 3 hours, 5 hours, something more interesting like that. Something more familiar to us, right? So let's do that. So in order to do that, so I'm going to write this time down here. Write the time when they meet as 250 over 75. And I'm going to carry out the long division right here so we can get a time that is more familiar to us. Now this time is in hours, okay? And we will be able to express that right now. So I ask myself, how many times does 75 go into 250? Okay? Okay, let's make a multiplication table for 75. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. And then I know 1 times 75 is 75. And then if I add 75 to 75, 5 plus 5 is 0. 5 plus 5 is 10, so I bring down the 0 and carry the 1. 7 plus 7 is 14. I add 1, 50. So it's 150. Okay. Now, I'm going to add 75 to 150. 0 plus 5 is 5. 5 plus 7 is 12. I carry the 1. That's 225. So what you can tell is that whenever I'm going to do a division, a long division, I like to make my multiplication table so that I'm not going back and forth when I'm doing the division. I just go straight. When I'm doing the division, it'll be very fast if I make this ahead of time. 5 plus 5 is 0. 5 plus 5 is 10. I bring down the 0, carry the 1. 2 plus 7 is 9. Plus 1 is 10. I carry the 1. 3. 300. Okay. Okay. Now, I add, if I add 75 to 300, that's 375. That one's easy. I'm not going to add, to 375, I'm going to add 75. 5 plus 5 is 10, so I bring down the 0, carry the 1. 7 plus 7 is 14. I add 1, 15. I carry the 1. 450. I add 75 to that. 5 plus 0 is 5. 7 plus 5 is 12. Bring down the 0, carry the 1. 1 plus 4 is 5. I have 25. I add 75 to that. Oh, that's going to be 600. And then 675. Okay? Okay. So I now have my multiplication table for all the digits from 1 to 9 of 75. So now I ask myself, how many times does 75 go into 2? Of course it doesn't. 25? Of course it doesn't. 250. 3 times. So I put my 3 over the 0 because I'm multiplying, because 3 times 75 is going to be 225, and I put it over the last digit that I was putting it into. Okay? Okay. So now I ask, what is 250 minus 225? Let me do that here. 250 minus 225. I want to take away 5 from 0. I cannot do that because, of course, 0 is less than 5. So I borrow from this 5, that becomes a 4, and this becomes a 10. I ask myself, what is 5 taken away from 10? 5. 4 minus 2, 2. 2 minus 2, 0. So this is 25, okay? So if I wanted to, well, and there's nothing to bring down here, so I could stop right here if I wanted to, and I could say, okay, 250 divided by 75 is equal to 3 and 25 over 75, okay? I could do that if I wanted to. Now, I know that 25 times 3 is 75, so I could rewrite that as 3 and 1/3. Okay? So that's a possibility. Now, let's suppose that I wanted to get a decimal expansion, okay? So I could say, okay, I would put now that I cannot, well, so now that I have nothing else to drop, that's when I have to start with my decimal expansion, if I want to do that. So I could put my decimal point here. Once I've put my decimal point, I can add a 0 that wasn't there before. I can drop this down here. This becomes 250. Aha. I know that it's going to be, again, 3. 3 times 75 is going to be 225. I know that when I subtract it, I'm going to get 25 again here. I'm going to add another 0. It's going to be 250. It's going to be 3. And it's going to continue forever like this. So it'll be 3.3 with a bar to indicate that it's going to be 0.33333 forever and ever. Okay? Okay. So let me get rid of this. Okay. So now, what we can say to answer our question, we had asked, when do Janet and Jessica's position match? At time 3 1/3 of an hour, right? So that's a lot more familiar to us. Now we know that an hour is 60 minutes. 1/3 of 60 is 20 minutes, right? Because 20 times 3 is 60. So we can now say it in even more familiar terms. They meet at 3 hours and 20 minutes, okay? So that would be when they meet. Now the question is, where do they meet relative to their starting position? Okay? Okay. So let me now get rid of this because we're going to plug in. So what I'm going to do here is I'm going to plug in this value into the position function for Jessica. Okay? So D1 of 3 1/3, I can rewrite this as 3 times 3 is 9 plus 1 is 10 as 10/3 of 10/3 hours, which is going to be 30 times 10/3. Okay. Which is going to be 30 over 1 times 10/3. Here, I just rewrote 30 as a fraction by setting it as the numerator and 1 as the denominator. 30 times 10 is 300. Divided by 3, that's going to be 100. Okay? So in other words, what we can see is that after 3 1/3 of an hour, Jessica is going to be 100 miles from the starting point here. Okay? So let's say right here. This is 100. This is where they meet. Okay? So let me see. So from where Jessica began, she's 100 miles in the direction that Janet was. And from where Janet began, she's 150 miles from where she began. Okay? This makes sense because Janet was driving at a faster speed than Jessica, so it stands to reason that Janet was able to cover a longer distance than what Jessica was able to cover in the same amount of time. But now I want to do something else. I want to show you something. Now that we know how to, well, if we look at this, oh my god, I can't believe I got tongue tied there. We look at these two functions. These are both lines, right? So we can actually graph these. Okay. So strictly speaking here, we've already solved the problem. We've already answered everything that the problem was asking. But now we can even go a little, I want to go a little bit further just to show you geometrically how we can, another way we can look at this problem. This is a line and slope intercept form with a slope 30 and with y-intercept 0. This is a line with a slope negative 45 and with y-intercept 250. The slope is negative 45 because that's the coefficient of the, in this case, t, but basically the independent variable. That what would have been in a normal equation, the x, right? Okay. So now if we graph this, it's going to look like this. Now I'll admit to you that my graph is kind of like a cartoon in the sense that it's not going to be perfect, but it's going to capture the important things. Okay, so for example, in Jessica's position, it has slope 30, but it has y-intercept 0. So it goes through the origin, and it goes this way like this, okay, with a slope of 30. Janet's line starts up here at 250. Let me try and use a different color here, so that we can see it for emphasis that it's a different line. And her line is going to be steeper, but it's going to be down. It's steeper because the slope here is negative 45. Okay? In other words, it's going steeper, it's going down faster. And what we can see is that this is the y-intercept of Janet's position. So Janet's is the blue line, as you guys are already aware. And of course, Jessica's line is the black one. Let me just label that here. We know that they meet. This is in this case, this is our time axis, and this is our distance axis. Okay? We know that they meet at the time 3 and 1/3 of an hour. And we know that, where did they meet? In terms of the distance, they met at d equals 100. Okay? And so what you can see is that if I were to draw a vertical line at any time here, this graph tells me where Janet and Jessica were at that time, relative to the position 0, which we see is where Jessica was. So for example, as I go along the time t, right, I can see that Janet's position is decreasing like this. So, and I can see that at that same time, Jessica's position is increasing here. So I don't want you to think that they went on zigzag trajectories. What I want you to realize is that this is kind of like if you were looking at this in real time, and you were let's say you were at this time period here, right? Whatever that is, let's say time t equals 1 hour. Then you can see that Janet is somewhere over here, and Jessica's somewhere over here. You see Jessica's over here, Janet's here like this. If you go closer here, then Janet is further here and Jessica's further here. You see? So this is kind of as we walk this way, this is kind of like where the position of the cars are in the trajectory. So in other words, if you were to flip this way, and you were to slide it down like this, you would see the cars coming together and they would touch at exactly this time. Yes. Now, we did not state whether they're going to get down and shake hands or So if they don't shake hands, if they just keep on going, then this will show them departing away. If they stop and shake hands or meet or whatever, it will occur then at 3 1/3 hour. And yes, well, I hope that you've enjoyed this example, and we'll continue discussing more examples like this. And thank you so much.